Hello everyone, this is Abhishek KV. Welcome to my YouTube channel. I hope you are all studying well. Yes, last class we discussed about the introduction and properties of inverse trigonometric function. In this session, I am going to solve some problems on inverse trigonometric function. Yes, examiner asked, find the principal value of following. Find the principal value of the following. See here, principal value is nothing but range of inverse trigonometric function. That's all. Okay. So this is the first type of problem in inverse trigonometry. This is for 1 mark. Either examiner asks the 1 mark question from range and domain of inverse trigonometric function, or find the principal value of the given inverse trigonometric function. These two are the only possibility for 1 marks. Okay. See, consider the first one. Find the principal value of sine inverse of 1 by 2. Sine inverse of 1 by 2. See, solution. Sine inverse of, we should check at which angle the trigonometric ratio, this is inverse trigonometric ratio, we need to check at which angle the trigonometric ratio of sine having the value 1 by 2. See, what is sine 0 degree? 0. What is sine 30 degree? Is equal to 1 by 2. And you should remember, throughout your class 12, you should use the angles in radian, not in degree. Okay? Then 30 degree is nothing but pi by 6. Therefore, 1 by 2 can be written as sine of pi by 6. Question arises. Sir, why? See, to cancel out sine inverse sine, we need the corresponding trigonometric ratio. Right? So this is possible only when, see, using the property sine inverse of sine x is equal to x, x should belongs to what? Minus pi by 2 to plus pi by 2. Minus pi by 2 to plus pi by 2. See, pi by 6 is between minus 90 to plus 90 degree. Therefore, we are able to cancel out. This implies, this is what? Pi by 6. This is the principle. That's all. See, first step. Consider sine inverse of 1 by 2. Sine inverse of at which angle the corresponding trigonometric ratio having the value 1 by 2, that is sine pi by 6. Cancel out because minus pi by 6 between minus pi by 2 to plus pi by 2. That is 60 degree. 60 degree is between minus 90 to plus 90 degree. This has the value pi by 6. See, let us consider the second problem. What about sine inverse of minus 1 by 2? What about the principal value of sine inverse of minus 1 by 2? Again, using the property. See, we know that sine inverse of minus x is equal to minus sine inverse x. Sine inverse of minus x is equal to minus sine inverse x. Therefore, this can be written as minus sine inverse of 1 by 2. Using the property sine inverse of minus x is equal to minus sine inverse x, we can write sine inverse of minus 1 by 2 is equal to minus sine inverse 1 by 2. Again, consider this minus and again the same step. Sine inverse of 1 by 2. See, sine inverse of sine of pi by 6. This one will cancel. Here we will be what? Pi by 6. That is, it has the value minus pi by 6. You don't have the rights to cancel sine inverse of minus sine inverse of 1 by 2. When you have the problem, you don't have rights to cancel this because we have minus. That's why we using the property sine inverse of minus x is equal to minus sine inverse x. This method is wrong. So we should consider sine inverse of minus x is equal to minus sine inverse x property. That is, sine inverse of minus 1 by 2 can be written as minus sine inverse of 1 by 2. Again, using the same method, sine inverse of sine pi by 6. Sine inverse sine get cancelled. We are remaining with minus pi by 6. This is therefore, at the last you should write therefore the principal value of sine inverse of 1 by 2 is pi by 6. for every problem. Okay, in this also the principal value of sin inverse of minus 1 by 2 is what? Minus pi by 6. Is it clear? Then look at the next problem. What about cos inverse of minus 1 by 2? Cos inverse of minus 1 by 2. Again, using the property. See, cos inverse of minus x is equal to pi minus cos inverse x. Right? Sin inverse of minus x is equal to minus sin inverse x. Tan inverse of minus x is equal to minus tan inverse x. Cosecant inverse of minus x is equal to minus cosecant inverse x. But in the case of cos, secant, cot, we have cot inverse of minus x is equal to pi minus cot inverse x. Cos inverse of minus x is equal to pi minus cos inverse x. And another one, secant inverse of minus x is equal to pi minus secant inverse x. Therefore, this can be written as pi minus cos inverse of 1 by 2. Then it removes the sign negative. Then we are able to apply at which angle cos has the value 1 by 2. Right? Because using what? Using cos inverse of minus x is equal to pi minus cos inverse x. Pi minus cos inverse. Now pi minus cos inverse cos of pi by 3 at 60 degree, cos has the value 1 by 2. Therefore, it cancels because pi by 3 is between what? Because pi by 3 between minus pi by 2 to, sorry, it has the, what is the range of the cos inverse x? 0 to pi. 0 to pi, right? Therefore, but here sin has the range minus pi by 2 to plus pi by 2. It has the range 0 to 180 degree, minus 90 to plus 90 degree for sin, 0 to 180 degree for cos inverse. Okay, therefore pi minus pi by 3, pi by 1, pi by 3, take the LCM 3, then need to multiply 3. What we multiplied in denominator, the same number multiplied by numerator. Here we already have the LCM in denominator, so multiplied by 1, same number multiplied by numerator. This is pi. This is equal to what? 2 pi by 3. See, principal value can be found using the properties of inverse trigonometric function. If it is positive, there is no problem. If it is negative, we should use the properties. I hope you are all getting it. Please write down. Yes. Let's move on to the next problem. Here, in all these problems, they given only one inverse trigonometric function. If they given, find the value of tan inverse 1 plus cos inverse minus 1 by 2 plus sin inverse minus 1 by 2. See, tan inverse 1, it has no negative sign, so there is no problem. Here negative is my villain. Okay, then we should remove that. Cos inverse of minus 1 by 2. Again, by using the property, cos inverse of minus x is equal to pi minus cos inverse x. Then plus sin inverse of minus x is equal to minus sin inverse x plus into minus what? Minus sin inverse 1 by 2. Then we have the positive values 1. That is, what is the x value here? 1 by 2. Again plus 1 by 2. Now we are going to apply. See, tan inverse of 1 plus pi minus cos inverse of, at which angle cos has the value 1 by 2 at 60 degree. That is pi by 3 minus sin inverse of sin of pi by 6 at 30 degree. Sin has the value 1 by 2. Therefore, what is tan inverse 1? See, 1 can be written as what? Tan of, at which angle? Tan has the value 1, tan of 45 degree. That is pi by 4. See, tan inverse get cancelled. We are remaining pi by 3 get cancelled, minus sin inverse sin get cancelled, remaining with pi by 6. See, this is pi by 4 plus pi by 1, 3, 6. What is the LCM for 3, 6, 4? See, 3 ones are, 3 twos are, sorry, 3 threes are, 3 twos are. Again, 3 ones are 2. Again, 2, 1, 1, 1. See, 3 threes are 9, 9 twos are 18. 18 is the LCM. See, 3 threes are 9, 9 twos are 18. Then, see, again, sorry, this is what? Sorry, 3 ones are, 3 twos are. Then it is 4. Then 2 ones are, 2 twos are. Okay. Then 2, 1, 1, 1. 3 twos are 6, 6 twos are 12. Here 12 is the LCM. Sorry. Okay. Then what is it? 12 is the LCM. We need to multiply 3. What we multiplied in denominator? The same number multiplied by numerator. Therefore it is what? 3 by plus. Since it has 1, we need to multiply what? 12. Same number by numerator. That is 12 by minus 3 into 4, that is 4 pi, minus 6 twos are 12, that is 2 pi. Then 12 plus 3, 15. 15 minus 4, 11. 11 minus 2. This is your what? 9 pi divided by 12. This is equal to what? We should write in simplified form. Okay? 3 threes are, 3 fours are. That is 3 pi by 4. This is how we are going to solve this kind of problem. This belongs to 2.1 exercise problem. This problem belongs to the exercise 2.1. Please note down this. Okay. Then look at the next problem. Find the value of tan inverse root 3 minus secant inverse of minus 2. Tan inverse root 3 minus secant inverse of minus 2. See, tan inverse of, at which angle we getting root 3? See, tan of pi by 3. See, tan 60 degree. That is sin 60 by cos 60. That is root 3 by 2 divided by 1 by 2. 2 to get cancelled. Here we will get tan inverse root 3. Therefore, tan inverse 60, tan 60 degree is equal to pi by 3 minus. See, but here we have problem. What is secant inverse of minus 2? That is secant inverse of minus x is equal to pi minus. This is what? Pi minus secant inverse of 2. Pi minus secant inverse of 2. Therefore, pi. We should put the bracket here. Plus into minus minus, minus into minus, plus secant inverse of secant of. At which angle we have the value to in secant? See, cos 60 degree is equal to root 3 by 2. Cos 30 degree is equal to 1 by 2. Secant 30 is equal to 2. Therefore, secant 30 degree, that is pi by 6. Pi by 6. This implies tan inverse tan get cancelled. Here remaining with what? Pi by 3 minus pi plus secant inverse get cancelled. Here remaining with pi by 6. Remaining with pi by 6. This implies what? This implies, see, what is the LCM for 3 and 6? What is the LCM for 3 and 6? 3 ones are, 3 twos are. Again, 1. 3 twos are 6. 6 is the LCM. See, that's why I told you. Basic information is very useful for studying class 12. You should know addition, subtraction, multiplication, division, LCM, HCF, polynomial functions. You should know the all basic things. Then only you succeed in your class 12. Okay? See, 6 is the LCM. 3 2s are again 2 pi minus. See, 6 into 1, that is into 6. That is 6. That is 6 pi plus. We already have 6 multiplied by 1. Therefore, pi, that is 3 pi minus 6 pi minus 3 pi by 6. This is equal to what? Minus pi by 3. This is the value of this. Let us move on to the second type of problems on inverse trigonometric function. Here, examiner asks, show that sin inverse of 2x into root of 1 minus x square is equal to 2 sin inverse x. And sin inverse of with the same LHS, that is sin inverse of 2x into root of 1 minus x square is equal to 2 cos inverse x. This is, and here 3 cos inverse x is equal to cos inverse of 4x cube minus 3x. 3 sin inverse x is equal to sin inverse of 3x minus 4x cube. We need to prove this. Out of these 4, you will definitely getting any one for 2 mark. Yes. Then how can we prove this? See, proof. See, to prove 1, that is sin inverse of 2x into root of 1 minus x square is equal to 2 sin inverse x. Consider LHS. That is sin inverse of 2x into root of 1 minus x square. Let us consider, let x is equal to sin theta. Why we take sin theta only? Why we are not taking cos theta, tan theta, cot theta? See, what you have in LHS, you need to prove what? Sin inverse x. See, x is equal to sin theta implies theta is equal to what? Sin inverse x. See, sin inverse of 2x is equal to what? Sin theta root of 1 minus x square is equal to what? Sin square theta. Then sin inverse of 2 sin theta. See, according to the basic identity, first basic identity, sin square theta plus cos square theta is equal to 1. Sin square theta plus cos square theta is equal to 1. What is 1 minus sin square theta? 1 minus sin square theta is equal to cos square theta. Root of cos square theta, that is root of cos square theta, square root square get cancelled. We are remaining with what? Sin inverse of 2 sin theta into cos theta. Again by using the formula. This is sin inverse of sin 2 theta. See, sin inverse sin get cancelled. We are remaining with what? 2 theta. This is equal to, what is theta? Theta is equal to what? X is equal to sin theta. Theta is equal to sin inverse x. This is equal to what? RHS. See, if I took cos inverse x, then it becomes what? 2 cos inverse x. That's all. See, 1 minus cos square x is sin square x. Sin square x is, here we have cos theta. That is 2 cos theta into sin theta. Again you have 2 theta. At last, since we took x is equal to cos theta for the next one. See, that is the solution for next one. Here we should take x is equal to cos theta and then we getting x is RHS as 2 cos inverse x. I leave that problem to you. See, what you have in RHS, that trigonometric ratio you should take. Okay, then look at this one. Look at the third one. See, 3 cos inverse x is equal to cos inverse of 4x cube minus 3x. See, we need to prove 3 cos inverse x as cos inverse of 4x cube minus 3x. Again, to prove 3, consider RHS. Here we need to consider RHS. Cos inverse of 4x cube minus 3x. 4x cube minus 3x. Let us consider x is equal to cos theta because we need to prove what? 3 cos inverse x. We need to consider that corresponding trigonometric ratio. Then this implies what? Theta is equal to cos inverse x. Then cos inverse of 4 cos cube theta minus 3 cos theta. See, that's why I told you in the introduction class. You should remember all trigonometric formulas. See, when I was in PUC, this was my prayer. Sin square theta plus cos square theta is equal to 1. 1 plus tan square theta is equal to secant square theta. 1 plus cos square theta is equal to cosecant square theta. Sin of a plus b is equal to sin a cos b plus cos a sin b. Sin of a minus b is equal to sin a cos b minus cos a sin b. Cos of a plus b is equal to cos a cos b minus sin a sin b. Cos of a minus b is equal to cos a cos b plus sin a sin b. Then tan of a plus b is equal to tan a plus tan b divided by 1 minus tan a into tan b. Tan of a minus b is equal to tan a minus tan b divided by 1 plus tan a into tan b. Sin 2 theta is equal to 2 sin theta. Sin 2 sin theta into cos theta. In terms of tan theta, sin 2 theta can be written as 2 tan theta divided by 1 plus tan square theta. 2 cos 2 theta is equal to cos square theta minus sin square theta. In terms of tan theta, 1 minus tan square theta divided by 1 plus tan square theta. Tan 2 theta is 2 tan theta divided by 1 minus tan square theta. Sin of minus theta is equal to minus sin theta. Cos of minus theta is equal to only cos theta. cosecant of minus theta is equal to minus cosecant theta. See, this is how you should remember. This was my prayer when I was in PUC. Okay, then what is 4 cos cube theta minus 3 cos theta? 4 cos cube theta minus 3 cos theta is nothing but cos inverse of cos 3 theta. See, get cancelled. We are remaining with what? 3 theta. This is equal to what? 3 into theta is equal to what? Cos inverse x. If you forgot, see, here we have cos inverse. We should have cos. Since we need to prove 3 cos inverse x, we should write cos 3 theta, not cos 2 theta. Cos 2 theta is cos square theta minus sin square theta. Sin 3 theta is equal to 3 sin theta minus 4 cos cube theta. 3 sin theta minus 4 sin cube theta. This is equal to sin square theta. See, therefore, this is equal to what? LHS. This is equal to what? LHS. Similarly, by taking, to prove 4, taking x is equal to what? Sin theta. 3 sin theta minus 4 sin cube theta is sin 3 theta. Sin inverse and get cancelled, remaining with 3 theta. 3 x is equal to sin theta plus theta is equal to sin inverse x. 3 sin inverse x. See, very easy. Yes, look at the next type of problems on inverse trigonometric function. See, prove that tan inverse of 2 by 11 plus tan inverse of 7 by 24 is equal to tan inverse of 1 by 2. These problems based on your fourth property, that is tan inverse A plus tan inverse B is equal to tan inverse of A plus B divided by 1 minus A. With tan inverse A minus tan inverse B is equal to tan inverse of A minus B divided by 1 plus AB. Either examiner has that property for 3 marks or problem. Very important. See, if the examiner has the problem, then you need to write the proof. Simply taking tan of theta plus phi using the trigonometric result, which we are already discussed in last class, right? So, based on the property, they given problem, either problem or property, 3 marks, pakka. Okay? Then, see, how to prove this? Consider to prove 1. To prove 1. Consider LHS. Consider LHS. What is LHS? Tan inverse of 1 by 2 plus, tan inverse of 2 by 11, right? Tan inverse of 2 by 11 plus tan inverse of 7 by 24. See, it is of the form what? Tan inverse A plus tan inverse B. Instead of A and B, A is 2 by 11, B is 7 by 24. Using the formula tan inverse A plus tan inverse B, that is tan inverse of A plus B. What is A? 2 by 11 plus B, 7 by 24 divided by 1 minus AB, that is 2 by 11 into 7 by 24. 7 by 24. See, this implies tan inverse of, what is the LCM? See, this is the prime number, this is an even number, 24. 24 into 11 is what? 264. Then 24 is multiplied by this side, 11 is multiplied by this side, that is 24 into 2, 48 plus 11 into 7, 77, whole thing divided by, again, see, this is 1 by 1, this is 24 into 11, again we have denominator of the denominator is 264, again LCM is 264, we need to multiply this side by 264, the same number multiplied by numerator of this denominator, that is 264 minus 7 2s are 14. See, we are remaining with what? This implies tan inverse of 47 plus 7, 48 plus 77, that is 125. See, denominator of the denominator get cancelled. 264 minus 14 is 250. See, 125 ones are 125 twos are. We are remaining with what? Tan inverse of 1 by 2. See, tan inverse of 1 by 2 is equal to RHS. Very simple. Using the formula, you should write using tan inverse A plus tan inverse B is equal to tan inverse of A plus B divided by 1 minus A. See, look at the next problem. 2 tan inverse of 1 by 2 plus tan inverse of 1 by 7. We know the formula tan inverse A plus tan inverse B. We don't know. We are not able to apply 2 tan inverse A plus 2 tan inverse X is equal to tan inverse of A plus B divided by 1 minus B. Both coefficients should be 1. But We also know the formula of 2 tan inverse x. What is 2 tan inverse x? Tan inverse of 2x divided by 1 minus x square. That is the fifth property, right? See, consider to prove second one, to prove, consider LHS. Consider LHS. See, 2 tan inverse of 1 by 2 plus tan inverse of 1 by 7. See, what is 2 tan inverse x? Tan inverse of 2x. What is x? 1 by 2 divided by 1 minus x square. That is 1 minus 1 by 2 whole square is 1 by 4 plus tan inverse of 2 by tan inverse of 1 by 7. See, now it has the coefficient 1 and 1. Now it is of the form tan a plus tan b. See, 2 to get cancelled. 2 to get cancelled. We are remaining with what? Tan inverse of 1 divided by, see here 4 is the LCM. Denominator becomes numerator. Here we multiply by 4. 4 minus 1 is 3 plus tan inverse of 1 by 7. Now we are able to apply the formula tan inverse a plus tan inverse b. See, tan inverse of a plus b 4 by 3 plus 1 by 7 divided by 1 minus 4 by 3 into 1 by 7. See, this is equal to what? Tan inverse of, see, 7 3s are 21. Again, both are prime. LCM is multiply of this. See, 7 4s are 28 plus 3 1s are 3. Whole thing divided by 7 3s are 21. 21 minus 4 is what? 17. 21 get cancelled. What is 28 plus 3? It is 28 plus 3 is what? 31. Therefore, we are remaining with what? This is equal to tan inverse of 31 divided by 17. This is equal to what? This is equal to RHS. Tan inverse of 31 by 7. Very simple. You should remember the formulas. See, I gave all the formulas in my notes. Go through the notes. Okay? Then prove that here we have, see, here we have two terms. Tan inverse a plus tan inverse b. Here, it is of the form tan inverse a plus tan inverse b plus tan inverse c. No problem. First, we are going to consider these two as tan inverse a plus tan inverse b. See, tan inverse a plus tan inverse b giving tan inverse of some value, say c. Then tan, it becomes one value, say tan inverse c. Again, plus tan inverse of 4 by 3. Tan inverse of 4 by 3. Now, we are going to apply again tan inverse a plus tan inverse b. See, first we are going to find these two, then these two, getting pi by 2. Tan inverse 4 by 2 plus tan inverse 2 by 11 gives you tan inverse of 3 by 4. Tan inverse of 3 by 4 plus here you have tan inverse of 4 by 3. 4 by 3. See, tan inverse of 3 by 4. What is tan inverse of 1 by x? Tan inverse of 1 by x is what? Tan inverse of 1 by x is cot inverse x. See, so cot inverse of 1 by x can be written as x. That is, it becomes what? 3 by 4. Tan inverse x plus cot inverse x. Tan inverse x plus cot inverse x is equal to what? See, this is your third property. Pi by 2. Sin inverse x plus cos inverse x is equal to pi by 2. Secant inverse x plus cosecant inverse x is equal to pi by 2. Tan inverse x plus cot inverse x. See, x is equal to what? 3 by 4. This is equal to what? Pi by 2. This is equal to what? RHS. See, very, very important. Yes. This is the fourth type of problem in your inverse trigonometric function. Examiner asks these questions for 3 marks. Anyone. Write the following in simplest form. Okay? 3 marks or 2 marks. 3 marks or 2 marks. In this type, you will get definitely one question. See, first one. We need to simplify this cos inverse of, tan inverse of cos is equal to 1 minus sin x. This is based on the formulas on trigonometry. This is based on the formulas on trigonometry. The all type of formulas already given in my notes. Please go through it. See, to simplify this, see, consider tan inverse of cos x divided by 1 minus sin x. 1 minus sin x. See, here you are going to consider the formulas. What is the half angle formula for cos x? It is cos square x by 2 minus sin square x by 2. One can be written as sin square x by 2 plus cos square x by 2. That is sin square x plus cos square x is equal to 1. Sin square x by 2 plus cos square x by 2 is equal to also equal to 1 minus. What is the Avogadro formula for sin x? 2 sin x into cos x. In the Avogadro formula, 2 sin x by 2 into cos x by 2. See, you should remember that. That's why I told you formulas is a very important rule. You should keep in your mind. Okay, this is not only important for this chapter. See, for your integration differentiation, you should know this. Know the result of trigonometry. There is a trigonometric derivatives, trigonometric integration, functions of integration on trigonometric functions, derivative on trigonometric function. See, for that you should need this. Okay, then see. This is of the form what? A square minus b square. What is a square minus b square? Algebraic formula. A square minus b square is equal to a plus b into a minus b. See, these are all your basics. That's why I told you to study class 11 and 12. You should perfect about the basics. Okay? Then a square minus b square is a plus b into a minus b. That is cos x by 2 plus sin x by 2 into cos x by 2 minus sin x by 2. See, it is of the form what? A square plus b square minus 2ab. But we should consider a square as this. A square plus b square minus 2ab. Because then it is what? Cos x by 2 minus sin x by 2 whole square. This is also equal to sin x by 2 minus cos x by 2 whole square. Okay? But we should consider cos x by 2. Why? To cancel the numerator. Numerator we have cos x by 2 minus sin x by 2. Denominator cos x by 2 minus sin x by 2 whole square. This get cancelled. We are remaining with what? Tan inverse of cos x by 2 minus plus sin x by 2 divided by cos x by 2 minus sin x by 2. Sin x by 2. See, divide throughout this by cos x by 2. Divide throughout this by cos x by 2. What we getting? See, tan inverse of cos x by 2 by cos x by 2 1 plus sin x by 2 by cos x by 2 tan x by 2. Again here cos x by 2 by cos x by 2 1 minus tan x by 2. Then 1 plus tan x by 2 1 minus tan x by 2. Using the trigonometric method. See, what is tan of pi by 4 minus x? What is tan of pi by 4 minus x? This is equal to tan A minus tan B divided by 1 plus tan A into tan B. See, what is tan pi by 4? It is equal to 1. Therefore, it becomes what? 1 minus tan x divided by 1 plus tan x. Instead of x, what we have? X by 2. Therefore, this can be written as what? Tan inverse of tan of pi by 4 plus x by 2. Pi by 4 plus x by 2. See, pi by 4. If it is minus, then numerator becomes minus. But in the numerator we have positive. That is tan of a plus b formula. See, this one get cancelled. Therefore, we are remaining with what? Pi by 4 plus x by 2. This is the simplest form. To solve the problems on simplest form, you should know the formulas. That's all. See, prayer. This was my prayer. That is formulas. Okay, done. Look at the next one. Tan inverse of 1 minus cos x divided by 1 plus cos x. Very standard formulas. See, 1 minus cos x is equal to 2 sin square x by 2. 1 plus cos x is equal to 2 cos square x by 2. That's all. If you know this formula, then apply this, get this. See, tan inverse of root of, what is 1 minus cos x? 2 sin square x by 2 divided by 1 plus cos x is 2 cos square x by 2. 2 to get cancelled. Tan inverse of, what is sin square x by 2 by cos square x by 2? It is tan square x by 2. See, this one get cancelled. See, tan inverse of tan x by 2. Tan get cancelled. Remaining with x by 2. See, very easy. I hope you are all okay. See, this is how you are going. If you know the formulas, then you can easily play this game. See, to play marble game, we need marbles. To play the mathematics game, especially inverse trigonometric, game, integration game, differentiation game. These are all like game for me. We need what? Formulas. That's all. In our mind. Yes. I discussed it on later. I consider this one, last one. Consider the last one. See, it is what? Tan inverse of cos x minus sin x divided by cos x plus sin x. I already told you. When you have this type of problem, we have tan inverse of cos x by 2 minus sin x by 2 divided by cos x by 2 plus sin x by 2. What we did? We did divide throughout by what? Cos x. That is, it is 1 minus tan x by 2 divided by 1 plus tan x by 2. There we divide throughout by cos x by 2. Here we divide by cos x. We remain with what? Tan inverse of divide throughout by cos x. Therefore 1 minus tan x, because sin x by cos x is tan x. 1 plus tan x. Again tan inverse of, what is 1 minus tan x divided by 1 plus tan x? Tan of 5 by 4. Here we have what? Minus in the denominator. Therefore it is of the form tan of a minus b. Get cancelled with 5 by 2 minus 6. Very easy. Okay? This is how you are going to solve. I hope you are all getting this. Yes. See, I am going to consider this one. See, cot inverse of 1 divided by root of x square minus 1. See, keep it in your mind. When you have this in trigonometric ratios, you should use the formulas. When you have inside this inverse trigonometric functions, a variable, you should substitute some trigonometric ratios. When you have trigonometric ratios, you should play this by using what formulas. When you have variables, you should substitute that. See, cos, sin, tan, cot, cosecant, secant, whatever. But you should substitute the suitable trigonometric ratio. See, cot inverse of 1 divided by root of x square minus 1. We all know sin square x plus cos square x is equal to 1. 1 plus tan square x is equal to secant square x. 1 plus cot square x is equal to cosecant square x. This implies sin square x is equal to 1 minus cos square x, or cos square x is equal to 1 minus sin square x. This implies tan square x is equal to secant square x minus 1. This implies cot square x is equal to cosecant square x minus 1. See, 1 minus function when we consider sin square x plus cos square x. But for these two, you have the first one is what? Function. That is function minus 1. Function minus 1. But here 1 minus function. See, here you have, see, consider this variable minus x. Where you will get the variable minus x? See, here 1 is constant. Constant minus variable or function. Okay? Variable minus x, variable minus x. So you should substitute x is equal to secant theta or x is equal to cosecant theta. Then it becomes function minus x. If you put x is equal to secant theta, secant square theta minus 1 is equal to what? 1 divided by square root of secant square theta minus 1. Let x is equal to secant theta. Theta is equal to what? Secant theta x. Let us consider this later. X is equal to secant theta, secant square theta minus 1. 1 divided by what is secant square theta minus 1? This is equal to tan square theta. See, square root square getting cancelled. We are remaining with 1 by tan theta. What is 1 by tan theta? It is cot theta with inverse trigonometric function cot inverse. Then you can easily cancel this, getting what? Theta. This is not only theta, you should replace. Theta is equal to what? Secant inverse. This is the simplified form. If you consider x is equal to cosecant theta, then you are getting what? Cot inverse of tan theta. Now you are not able to cancel that. That's why we should substitute the correct one. It is in denominator. If it is in numerator, you can directly go through this formula. That is x is equal to cosecant theta. Since it is in denominator, 1 by tan theta becomes cot theta. Where you will get tan theta? From this formula. X is equal to secant theta. Similarly, to solve this, 1 by this tan inverse of numerator. If it is in x square minus 1 is in numerator, you can directly put x is equal to secant theta. cosecant theta. Then cosecant theta minus 1. Cosecant square theta minus 1 is cot square theta. Square root get cancelled. 1 by cot theta tan theta. Tan inverse of tan theta. Tan inverse can get cancelled. Remaining with theta. Theta is equal to what? Cosecant inverse x. See, this is how you are going to play this game. I hope you are all getting this. Yes. Let us consider the last type of problems on inverse trigonometric function. See, example like that. This type of questions for 2 mark. Find the values of the following. See, cos of secant inverse x plus cosecant inverse x. How do we solve this? See, cos of what is secant inverse x plus cosecant inverse x according to the property. Sin inverse x plus cos inverse x is equal to pi by 2. Secant inverse x plus cosecant inverse x is equal to pi by 2. Tan inverse x plus cot inverse x is equal to pi by 2. Therefore, this can be written as pi by 2. This is what is pi by 2? Cos of pi by 2. That is cos 90. 0 degree. Is it clear? Very simple. See, let us consider this. Sin of pi by 3. We solve this from left. Okay? It is like chain. We should separate this chain from left. Minus sin of minus 1 by 2. What is sin inverse of minus x? It is minus sin inverse x. We already have minus. Minus into minus what? Plus sin inverse 1 by 2. Sin inverse 1 by 2. This is equal to what? Sin of pi by 3 minus sin plus sin inverse of, at which angle we get 1 by 2 in sin of 30 degree. That is sin of pi by 6. Sin inverse sin get cancelled. We are remaining with what? Sin of pi by 3 plus pi by 6. That is 30 degree plus 60 degree. 60 degree plus 30 degree. This is equal to what? Sin of pi by 2. What is sin pi by 2? That is sin 90. This is equal to 1. Yes. Consider this problem. Sin inverse of sin of 2 pi by 3. What is the answer? I think your answer is 2 pi by 3. Sin inverse sin get cancelled, sir. According to the property, it is 2 pi by 3. But your answer is completely wrong. Why? See, if you consider sin inverse of sin x is equal to x, that x should be belongs to what? X belongs to minus pi by 2 to plus pi by 2. Minus, that is minus 90 to plus 90 degree. What is the angle for this? See, this is in radian. 2 into 180 divided by 3. 3 1s are 3 6s are 6 2s are 8. 6 2s are 12. That is 120 degree. Is it 120 degree between minus 90 to plus 90? No. So you should reduce this angle between minus 90 to plus 90. How? See, we are all know. See, sin inverse of sin. We are all know sin of 180 minus theta is equal to what? Sin theta. According to ASTC rule, in the second quadrant, that is 180 degree. It is in second quadrant. Sin and cosecant are positive. Positive becomes positive. 180 minus 180 plus sin ratio becomes sin only. Then 180 minus theta is theta. See, sin of, see, this is 120 degree. Pi minus 60 degree. See, 180 minus 60 is what? 120. Therefore, this can be written as sin of 180 minus 60. This is equal to what? Sin 2 pi by 3. Sin 2 pi by 3. Sin inverse of, what is sin of 180 minus theta? It is sin theta. Instead of theta, what we have? Pi by 3. It is equal to what? Sin pi by 3. Sin inverse sin theta. Now we are able to, now we have rights to cancel this because pi by 3 is between, what is pi by 3? 60 degree is between minus pi by 2 to plus pi by 2. Therefore, the answer is pi by 3, not 2 pi by 3. Please remember this. See, these are all about the problems on inverse trigonometric function. Totally 5 parts. See, in this chapter you are going to getting totally 8 marks. In this chapter you are going to getting totally 8 marks. One question for 1 mark. This question is based on either domain and range of inverse trigonometric function or principal value of the given trigonometric function. See, out of these two concepts only you are going to get definitely 1 mark question in your part 3. Then two questions for 2 mark. 2 questions for 2 mark. One question is definitely based on the property. You have totally 5 main properties. Each property has 3 sub-properties. That is 5 into 3, 15. But one property has 6 sub-properties. That is sin inverse of minus x is equal to minus sin inverse x. Again 3. Then cos inverse of minus x is equal to pi minus cos inverse x. Similarly secant, cot. For sin, cosecant, tan. Then totally you have 18 properties. 18 properties. Out of this you will get one question. Prove that this property or that property. Remember this is not only important for these 2 marks. It is very basic need to study integration, differentiation, application of derivatives, application of integrals. You should remember that and you should study that. Okay. Then one question is on problems. One question is from problem. Problem is for 4th type. That is simplify the following or find the value. Find the value of the following. Find the value of the following. This is for 2 mark. Again, this is for 2 mark. This is for 1 mark. These are the types. These are the fields you are going to need 2 questions. Then one question for 3 mark. This question should be based on tan inverse A plus tan inverse B is equal to tan inverse of A plus B divided by 1 minus A. You are going to getting problems on this type. We discussed this, right? 3rd type of problem. Either you get property, prove that this, or using this you need to almost examiner like as problems using this property. Problems using this property. Or yes, almost this one. Almost you are getting the 3 marks question in this problem. See, totally this is for 3 marks. 3 plus 2, 5, 5 plus 2, 7, 7 plus 1 is totally 8 marks. And this completes the inverse trigonometry. See, this is more than enough for your annual examination. Properties. First you should learn domain and range. From that domain and range you need to find the principal value. Then the properties of inverse trigonometric function. Then these 5 types of problems. This is more than enough for your annual examination. Thank you everyone. If you have any doubt, please post your doubts to my WhatsApp number 9900423635. I will meet you in the next class with the next new chapter, that is 3rd chapter of your class 11, that is matrices. Thank you everyone. Bye bye.